where speaking aspirations get you in the end, but I can recommend, so sign up for this speaker event for sure if you would like to speak. I'm very happy to be here. It's also very nice om eens in Nederland te zijn, because everybody's tall here and I actually feel normal. It's super nice. Okay, I want to show you a bit today where we are with artificial intelligence in Java and what we can do with it and how it can help us. So a first question I would like to ask you, who likes to juggle around with date and time formats in Java? That's like 3 people, good. So, let me just show you something we can do already today in Java. It's with the LangChain4j framework that lets us connect to basically any model from any provider, almost. Let me show you a little demo here. We create an OpenAI chat model here that we're going to use. Then we write a program. It looks as follows. It's just an interface saying, extract date time from a text with a little LangChain4j annotation user message that it has to extract the date and the time from it, being the text. And this will return us a local datetime object, or the real Java object. So when we create this little interface with LangChain4j, we can use it, and we can say, extract datetime from this little text here. It was exactly 3 days before St. Valentine's Day of 1998, just 15 minutes shy of noon, when Hendrik decided to go cycling through the tulip fields. It's localized. Now, if we run this, we will get a local datetime object back, and we'll print it to the console. Let's have a little look. So this is GPT 3.5 running in the background, and it tells us this. So the year is correct. It's 3 days before Valentine's Day, and it's 15 minutes shy of noon. Our work is done here, right? Not only did it get super easy, it's also something that was simply not possible before the arrival of large language models in this case. Something else I want to show you that you could maybe use in your daily programming life. Me, as a Java backend developer, I'm not such a fan of the front-end side, but now we have ChatGPT. Let's give you a little demo here. I just have 2 prompts here, or like questions. I'm gonna drop those in ChatGPT. So the first thing I'm gonna ask is basically to create me some synthetic demo data. So I want 10 lab result measures, because I work in drug development, in JSON format. And there it goes, and it gives me this thing straight in JSON format. That's also partly how LangChain4j that you just saw works in the background. We get a lot back in JSON format, and then we parse it for you, and then you can just continue with your Java object afterwards. So any test data you want, ChatGPT is pretty good at any possible format you can think of. And then what I am asking it then is to generate an HTML page where my lab physician can actually enter just this type of data. And then when they click submit, then we want to upload this to, in this case, localhost 8080 lab results endpoint. And I'm asking it to put everything in one HTML file, including CSS and JavaScript, because I'm too lazy. I just want to copy it once. And then there it goes. So it starts writing this HTML file for me, including the CSS. Now it's writing the body. Then it's going to write me the JavaScript. And it works, most of the time it works remarkably well, just like that. Let's see. We'll come back later when it's done writing. So it's programming for us. We will look at the next thing here. Something else that they're super good in, these large language models, is writing queries, SQL queries, or even for Neo4j kind of graph bases. The example I would like to show you here is a little Quarkus demo, which, by the way, is open source. It's Quarkus LangChain4j examples. If you Google it, you'll find it. I'm just getting the application up and running. And let's see if, meanwhile, ChatGPT is done here. Yes, including the JavaScript, sending it off to our localhost endpoint here. Okay, just to show you if this works or not, I just copied all that code, so whoops, and I'm gonna paste it in here. And this is what I made out of it, a lab results entry form with all these measurements that we want to submit, and the submit button, and it will probably work, or it will almost work. So I'm using it all the time now. I'm finally managed to make full stack apps because I can finally make myself a front end. Okay, let's see if this Quarkus app is up. No, it's not. The reason why, it's already open somewhere else. That's annoying because I'm just wondering where. Yeah, running a bit too many Quarkus apps all on the same port. Okay, let's see if we get there this time. Okay, it's not looking much better. It's still busy. So. Anyway, so this is has a little movie database behind it. This little example. It's not looking good. Okay, I'm not going to start killing the process right now. Anyway, what it does is that you ask, for example, to this chatbot, I want to watch a movie from the 90s, fantasy, a very popular one. And it's what's happening in the backend is that any model you want will turn your question into an SQL query on your specific database schema. And it works almost every time. It's really impressive. It will give you something like select star from your movie database where category like fantasy and where the year is between 1990 and 1999, and then rank and take the best one. So this makes a whole new range of applications possible where your user can interact with the database much easier. Of course, watch out if you let users interact with your database, because this one you can say also drop all tables, and it will do it. Okay, another thing when you start working with large language models and AI models in general, you have to start thinking meta. So LLMs can generate code for you. They can also generate the unit tests for your code. Then you can run it, and you will probably find a couple of errors, both in its code and both in its unit tests, but together it's a really strong combo already. They can also rank their own solutions. They can generate steps and then call LLMs to execute every step in a row. So like a little tip there that I learned yesterday, apparently, if you ask something to ChatGPT normally and you say, think in steps, the answer is just already so much better. And they can also decide which tasks are suitable for themselves to solve or where they have to call other tools. So an example you see there is the user has a question, and imagine you have some documents, database, whatever, from, say, your company that you want your user to kind of interact with. Then you can make a query router, which is a large language model, again, that decides, can I solve this question alone? Do I need to do a web search? And it will also make the query for the web search. Do I have to query my database? It will write your query. Or do I do a semantic search, which is a very LLM-specific way of searching things with the same meaning inside of your documents? And then it will put all these results together, send it to an LLM, and you will get an informed answer. So they are capable of doing that already today. Okay, so that was just some warmer-ups. Now, today I want to show you how AI actually works, very quickly. Then how it can help you with software development, where you can put it into your apps, and a little future outlook, will we all lose our jobs now? So I am Lize Raes. I'm working in bioinformatics, so drug development and gene sequences. And I'm also head of the AI task force in my company, which is a really exciting job, I must say. I'm also a collaborator of the LangChain4j framework, which lets you connect to large language models very easily, straight from Java. And I'm an AI transition consultant at OpenTide. So we help also companies to see where AI can bring them most value, either in their internal processes or in their product. Okay, before I start diving into details, I'm very curious who of you is using AI tools like ChatGPT regularly? Okay, that's like half the people. Who is using an AI coding assistant regularly? Oh yeah, cool. Like 30% or so. That's interesting. Who of you is not using an AI coding assistant because it doesn't work well enough? Okay, a couple. Interesting. Good. Now, let's have a look behind the scenes in AI. So AI, deep learning these days is typically you have a neural network of some form where you pass through different layers with different starting values, and then they propagate based on how much from each node goes to the next node. That's the neural network you see there. Now, to determine how much from every node goes to the next layer and goes to the next node, we have to find the weights. And these can be automatically trained by giving this neural network, by sending through training data, which has like input and the desired output. And so the more training data you send in there, the better these weights will become, and the better your model will become. So it's very much like our brain that sees examples and outcomes, and then you get these synaptic paths in your brain also that gets reinforced. Now, once you've trained your neural network, you have what we call a trained model, or simply a model, which is, in essence, a calculation scheme. So when you want to use it then, you can have any type of input. So we've been looking at large language models a lot. Their text goes in. But you can also have images or heat maps or like anything you can think of that's digitalizable. Then it goes through these calculation schemes. There's a lot of parallel matrix multiplications going on. That's why typically you need some dedicated hardware to make this happen fast enough. And then comes out whatever you train it to output. So in this case, it's an image classifier. It will output a label, something about this image. But it can be text, it can be the next word, it can be even depth estimates, it can be really anything you train it for. Now, when you have this model, how do you use it? So we know it typically as software as a service. So like if you use ChatGPT, they wrap their model in a tool online. But they also offer an API, for example, so you can directly from Java or from anywhere basically call this API and get results as well. But then you're stuck with their terms of use and their pricing. You can also have your model in your private cloud. Then you have some more control over it. You can run it on-premise on your own servers, but you need some dedicated hardware then. And also these models, you have to have them open source or in a way that you can actually use them. For example, the models of OpenAI, GPTs, are not open source. You can't just download them. And then the last one is local. There's been a lot of progress in the models recently. So I just wanted to also show you, let me escape here. So I have a MacBook here, and it's not super powerful, but I can run a small model like Phi3 just here. It's the download of 3.5 gigabyte, and it's almost as good as GPT 3.5. So that's the old free version of ChatGPT. I could again generate lab measurement results from drug development lab. And typos are no problem, that's very nice, in JSON format. Nice. Okay, it makes it a bit more complex, but so this is just running now on my laptop here with hardly any dedicated hardware on it. It's super fast. Oh, it's gonna write me an article. Cool. It's a bit overzealous. I wonder, can I try Control-C? Yes, okay. But as you can see, the progress is really fast. So Phi3 is a Microsoft small model that they open sourced. That came out about a month ago, I think. It's really very, very nice. Good. Now, for our daily life in software development, what can AI do for us? So this is a software development lifecycle. Added a little Lize factor there, the documentation, which seems always forgotten. It's kind of very important for the people that come after you and have to touch the code. So if we have a look at the different aspects here, when it comes to requirement analysis at the beginning, you can imagine that typically your customer or someone else defines what they want the thing to do or what they want to change. And then we have to turn that into a proper requirement analysis and technical specifications that get approved and everything. There, of course, just like ChatGPT out of the box comes in already super handy. And then you usually have to make some documents for legal, for your developers, for your customers. So all this throwing around and formatting of text, that's already super covered. And it can also help you with finding the edge cases right away, which is really nice because then you don't have to find it out when you're actually implementing and running into these problems then. When it comes to design and architecture, it's a great brainstorming partner, even for design IDs, and it can output images and everything. Again, the edge case is there. You can discuss with it, and it's really helpful there. Then when we move on to implementing and coding, I'm going to dive into a bit more detail because it's the core of what most of us do, I think. So this is a little prognosis that it's the most popular programming language by decade, and it's saying for the 2030 decade, it will probably be English. And I think that might be true, and you will see later why. And I think it might also arrive a bit sooner than 2030, the rhythm things are going at the moment. So we have our existing coding assistants. I think everybody had touched them already once or knows what they do. For example, there's GitHub Copilot, IntelliJ AI Assistant. They're helpful in a lot of cases, but then they're also not that good. Especially when you're touching multiple files or you change, it's a big change in some kind of spaghetti code where a lot of related things also change, it typically fails. So there are efforts. For example, this is a group of Deutsche Telekom that's building an advanced AI coding assistant using the principle of graph databases. So they will encode this code using connectors that have a meaning. So has file and has function and has field, so that when you ask a question, instead of just doing a search for parts in your code that look like it, it really knows, oh, but this is using all these fields and they are then used in these and these and these other parts of your code. So you get a way more coherent answer. So I'm looking forward. This is currently being built. Another one I want to show you that's really we're trying at home, it's Cursor. So you could just go to cursor.com, you can download it for free. And it's just a very nice code editor. It's a fork of VS Code. And I'm just going to demo you what it does. If I can put it a little bit bigger. Zoom in. It's a bit better. Sorry. Okay, I'm not a usual VS Code user. Good. There we go. So I've loaded a feedback analyzer program that I wrote. It basically looks like this in the front end. You give some fields about yourself, you give your feedback, and then it will automatically analyze your feedback, and then there's another dashboard linked to it. So what I'm prepared here is I want to add a field profession to this web form, and right after the field gender, that's already there. And then I want to use this profession, let's make it value, throughout the rest of my app, just like gender is used further on. And this is going to touch a lot of files. I'm going to click with entire code base. So it's going to go through all of my files. No thanks. And then it starts telling me, OK, first thing in feedback.html, so this page we just saw, you're going to need this profession field, right? Then you have to update your JavaScript as well, my data transfer object, and so on, and so on, and so on. So that's a lot of files to change, and that's correct. So the nice thing is I can open it like this, and then take this one. Yes, just apply this to this current file, yes. And now it will give me a div. Let me see if I can scroll through it. Yeah, it's going to give me the div. So it's going to add my profession field here. And then later on as well, when we make our object, when we retrieve them. And then I can say, I accept this. Then I just have a look. So I'm still checking myself, right? Because this is not necessarily correct. You always need to check it, test it. But it saves so much time. So JavaScript, yeah, that was already done. Feedback DTO, it's in my data storage objects. So sometimes it also really gives you the link to jump to the file. It's not perfect yet. So I have it open now, and if I say, okay, I want this as well, then it's gonna add it there too. Voila. So I here get my getters and setters, super nice. And you can go through your files like that, and I just love it, because it's way smarter than the standard AI assistants. Okay. What else do we have? Yes, you may have heard of Devin. So it's a software agent. It is capable of taking a GitHub repository and then fixing it. So it's able to do certain tasks of Upwork, for example, and really change the code and make it work, and make it work correctly in about 15% of the cases. There's also an open source variant, SW agent from Princeton. Yeah, just look at the tutorial or try it out for yourself. It's amazing. So you see these, the LLMs have gotten tools like scroll up, scroll down, go to a certain file, make a change, run your code, check the terminal, see the error, go to the file, fix it, and it's just doing the whole thing alone. It's very fascinating to look at. Now, it's still not super great. Like this one, I think 13% of the cases it managed to resolve. But I think these things will just get better and better. Like everything is getting better at a crazy pace these days. So it's really exciting to see where this is going. Okay, some tools that you can already add to your GitHub repository right now is CodeRabbit. Yeah, we all know that. So CodeRabbit AI will do a pull request review, and it's very nice because you can still do your normal pull request review yourself, but it's gonna find you a couple of things typically that I overlooked, and it gives you the fix right away, and you can do apply diff. Super nice. Another one is DozoBot, also just a GitHub app that you can install on your repository. And this one looks at issues that are opened and gives a suggestion how to fix them. And it's not always right, and sometimes it's a bit of overkill, but sometimes, like in this case, it can really figure out really complex issues and point you to the solution. Okay, and then yeah, documentation. Of course, it can help you right away. So in most coding assistants, you already have a generate Java doc button. I'm also hoping that tools will come to, for example, when you make a pull request, that automatically look which parts of the documentation should be updated, given the code you updated, for example. Okay. When we move on to testing, so for generating unit tests, it's amazing. It's not always perfect, but then at least it gives you a very big overview of all the edge cases that you may not have thought of yourself or that you didn't want to write out yourself. So it's really cool there. It can also generate your synthetic data, and for everybody doing integration testing with Selenium or Cypress, for example, this horrible syntax, and you actually know what you just want to check, also there it can help you turning it into the correct code. When it comes to deployment, I know at our company, our IT group is so happy with, I mean, we're using the Bing Chat Enterprise version because we don't want to throw all our info to OpenAI. But they're so happy because they're touching different operating systems, different servers, different frameworks all the time. And so to get into something new, it's extremely helpful. It saves them hours and hours and hours. And then when it comes to maintenance, some companies are already using AI for their log file analysis, specifically in banking and security, because AI is better able than any rule-based system to detect abnormalities and security breaches. But you could also use it if you start logging in a different way. You can use AI to automatically analyze these log files and find out where there's bugs, where there are issues, what's used a lot, what's not, and gives you very interesting diagnostics on your code. As well as when it finds a bug, it can say it's probably linked to this code here, or this bug is this severe, and then actually even suggest what the next step would be, what you best would work on. For example, these 3 bugs are pretty severe, they're all linked to this part of the code, and we happen to have a feature request about this part too, so why don't you take them all together? Okay, that's all dream tools. We still have to build them. So reason one why we are not out of a job is that there are so many tools possible these days, but we still need to build them, a lot of them. Okay. Atlassian is doing a try at making a product that for this whole software development lifecycle helps us, but it's with a waiting list. I haven't tested it out myself. So the whole ticketing and coding should be included with all the Atlassian projects, and they also promised that you can integrate non-Atlassian projects in there afterwards as well. And GitHub Copilot has a similar initiative with GitHub Copilot Workspace. I heard it's not that great because, again, it's using the normal Copilot code assistant that is like limited in what it can do. But I think these things are gonna get better. Like in a year from now, we'll talk again. Good. Now, it looks like AI can solve all our problems. And some people are using it in that way, like it's duct tape. If it can't be fixed with duct tape, then you have to use more of it. So you see people throwing AI at everything these days. And at the first glance, it might be true, right? Like duct tape, you can use it to paint things, or to tape your boobs together, or fix airplanes and take them to the moon, or have just peaceful parenting. So AI also promises to solve a lot of things. But apparently duct tape is not the solution to every problem. And it's the same for AI. It has its problems where it's very valuable, and then there's the other things that maybe we just want to stay with our old linters and our old security and dependency checkers. They perform just fine, right? So use the right tool for the right job. Now, if we want to use AI inside of our apps, what can we build with it? So a first thing would be to look to the AI application stack. So we are working on the application level there in blue. Underneath, yeah, sorry, the A of data fell off. So for training models, there's this whole process of gathering data and cleaning it up and formatting it correctly and then training the model. And in the model also, like there's versions, there's feedback loops, there's a lot of stuff going on. But the nice thing is we can summarize this for us as software developers that are working only on this application layer like this. We just stay in our normal DevOps world, and we are going to use these models as an API, and we don't not really care what happens in these ML ops below. That's work for the data scientists. They're good at that. Now, if you happen to have a data scientist in your team, so a machine learning expert, so to say, it's very nice because then you can ask for a very specified models that perform a specific task very well. But if you don't have them, there's already so many open source models out there that you can just use as an API. It's also important to keep in mind that these days we have models already out there that can predict basically anything. So you see here an example of a model that will predict how your hair falls. And it sounds funny, but then if you know that Disney, they have like a whole department that spends months and months for every Disney movie on just generating the hair. It's a very hard problem. So now we have a model that can help us with that. And the other one you see, depth anything, it's an open source one. You go from an image to depth estimates. Also super handy for simulations and for modeling. Now, how are you going to use these models? Typically via an API. So I think a lot of us know like OpenAI API to talk to the GPT models, but also AWS has models, Azure has models, Google has the Gemini models. So you can use all those. This one I just wanted to show because it's a lot of fun. You can directly use the GPU from JavaScript, so the GPU of wherever your website is running on. So let me show you what that gives. Yes. So it's not I that built it. Okay, let me see if this works. At the moment, I'm just using my normal CPU. Voila. And so it's a vision recognition model, but it's very slow. So you can see here 5 frames per second. Now, if I'm using this web GPU, we get at 30 frames per second. It's really nice because it has a lot of amazing applications like this. Oh, I'm even twice. But that's not a thing. Okay, anyway, confusing. All right. Okay, and you can also have models turning locally. So more and more devices, laptops, smartphones have these days chips integrated in them that are AI capable in some version of another. And like when you want to address that right away, you have in Java things like Project Panama that makes this native integration much better and much faster. Tornado VM, they search to use your GPU directly from Java. And what comes also in handy is Project Loom, the virtual threads in Java, because all these calls to models, whether you do it via API or to your local models, there's also always latency. It always takes a time to get an answer back. So then if you want to do a lot of parallel calls, virtual threads will help you a lot there. Now, what do we want to build with it? So the first very obvious thing is chatbots. Everybody heard about chatbots now. They seem cute, but they can actually solve a lot of problems when they're well designed. And that's actually quite hard to design them well, but when you have them made well, you can guide users through complete workflows tailored to them. So instead of having everybody fill out the same huge web form with half of the data that's completely irrelevant, your model can know what data to really ask for this specific person, pass on into another state that is tailored to whatever the person wanted to do, and just really only ask that. And it also saves us from this hell of selecting your nationality when you're Swiss and you type S in the drop-down, and you see all these fields starting with an R, and then like first S country all down, that kind of stuff, that's done. Also selecting your age. So if you're interested to know how this works, I'm giving another talk with LangChain4j where we really build a chatbot, and then you can see how smooth this goes. Also, when your user needs to know specific information about your company, you can upload your documents, and this AI chatbot can give this person just the information they needed in a language they understand, even in a foreign language. But then it goes beyond chatbots, what you can use it for. So you can format data, you can integrate all types of data from your data lake that were in different formats and integrate it. You can parse all kinds of documents by just saying, okay, on the first line you find the date, and in the third line you find the title or whatever. So normally we would parse the thing line by line and extract this all. AI can do that super well for you. For generating, it's also super cool. So medical advice, psychological advice, stories, images, education material, that's all possible. And then for analysis, so this little tool analyzes the feedback and gives it a certain severity and impact category, which is also really nice. Okay, just to show you how good the models are already these days, this is some paper from Google Research. They made Amy, a diagnostics tool for medical help. And it outperforms real doctors on basically every possible level, including empathy, very interestingly. Yeah, because it doesn't get tired, I guess. And then the graph on the left is also interesting. So you see there how a clinician performs in blue without any help, in green when they can search the web or their encyclopedia, basically. Then in yellow when the clinician is assisted by this Amy model, and then in red if it's the Amy model alone. So you actually would not want to see a doctor anymore. Good. But the interesting thing is that's the progress in the models, and now we have to build the applications around this. It's really exciting times. Okay, what does the future look like? So what we see, the trends in AI models currently is that you get better quality models, but also the size and the costs are dropping. As you saw this Phi-3 model, that's almost as good as GPT 3.5. It's about 100 times smaller. They train it in a smart way by giving it children's books and constructing its knowledge just like a child learns, very interestingly. And so they made it so much smaller. When it's smaller, it's faster, it's cheaper. They are hallucinating less, and we are mitigating a lot things like source, mentioning your sources, right? Because often these models just invent something, but people are working on that and it's getting better and better. We also see dedicated models appear for very dedicated tasks. For example, you have re-ranking models. They're tiny and super fast models that tell you how well a certain part of text fits to a question. Like it has specific applications, and it's about 100 times faster than calling an LLM to do it, and also so much cheaper. And we also see this trend towards on-device models. We also see like how good these models are becoming compared to humans. So this 100% is the human baseline, and AI has caught up with humans in terms of image classification first, then anything language related, then multitask language understanding is this pink graph, and now competition level mathematics are also catching up super fast. So the Stanford University had this little quote: as quickly as things are moving, each year is likely going to be magnitudes crazier, whether the world is ready or not. Now, will we all lose our jobs? We have seen other revolutions in software where things all of a sudden got much easier or got much faster. But what we've seen at the same time in the graph is that there's been always more and more software developers. So we'll probably not lose our jobs. The reason why is that maybe certain things we are doing in our daily life at the moment can be automated. So these jobs we are going to lose. But outside of what was possible now becomes just a whole new bubble of what's possible together with AI. And we're still needed there. Holy Commons also put it very nice. I'm just gonna write a little part of this. So I'm gonna read part of this, why we are needed still. After we've written or copy-pasted the code, our job is to get this code from the internet all the way into production, debug the code again, understand the computer's deepest secrets, try and stop the computer system from going completely mad, work with colleagues to integrate incompatible systems, manage stakeholders, very important, debug the code again, since it's doing something in production which no one has seen before, and then redefine the problem again. And I think we are doing more than just writing the code, we are doing so much more, so that's why I think we're always going to be needed. My last question to you is, we now have this superpower to get faster in what we do, automate more things than were possible before, and build a whole new generation of apps. We can abuse this. We can use it to say, we do user profiling now automatically, and we see which people are more vulnerable to impulse buying. We get them in debt more, we get more money out of them. We can do that with AI. But we can also build super nice tools for a cool future, to make education more democratic, to make medicine more democratic, to advance better in drug development, and so on, and so on. So I think if you build what you love, and if you love what you build, you help the world move to this place that you would like to see it in. Okay, I have a talk in about an hour from here about LangChain4j for the people that want to have a technical dive in how you build a Java app on top of LLMs. Yeah, and apart from that, if you want to be in touch, just connect on LinkedIn. I accept everybody. If you have questions, I'm here, or ask them on LinkedIn. And thank you very much for your attention.